qualitative. Yeah, we are here in a reservoir situation, which is not the ideal place to demonstrate multi-habitat sampling because you need the flow, the current. If you have a reservoir, you might do it with a grab or do it with dredging. You will see that later on. But from the first side, we have a nice homogeneous beach where we have macrolithial, mesolithial, microlithial, a little bit archive maybe, but it's quite homogeneous. And Patrick or whoever wants to take the samples, we will make a series of 4 maybe to show you how we do it, and then you can do it by yourself or whatever. We have macrophytes here. I don't know if you want to take macrophytes too, could try to do it, but on the other side, for the Danube, a situation like this is not the typical one. It's not a flowing river, and Benno told me that the water level is changing quite quickly here. So we would like to go down, and now what I see here is that at the water level now there are some algae. So the permanent wetted area is characterized by algae cover. So if you don't have algae, don't take samples, but we can have a look down there. Otherwise, I wouldn't like to stay too long in the sun, otherwise I will
Kaputt.
Be kaputt, yeah.
Attacking the beach.
Always go upstream, of course, and in that case the water is not turbid, it's easy to check the substrate. I always take the brush first and to brush the cover, the organic matter into the net, and then maybe to destroy it with the brush with the other side, or with some screwdriver or something. What I guess is not necessary here because it's quite loose, the gravel is quite loose. But what we need here is to make a wave, because the water is more or less stagnant here. And this is also important information for the protocol, of course. If the water body is stagnant like this, and usually at the end, I try to get really deep into the substrate with the help of the rubber boots, and producing a wave with the help of the boots, of the legs. Okay, so I think I'm now, let's say, maybe 10 centimeters in the substrate, making some wave. Maybe you just lift it up like this to catch the animals. If there are some, I'm not sure. But I will do this 4 more times. In large sections, or in large rivers, I have an average distance from one to the next. This is about, I don't know, 2, 3, 4 meters like this. Because maybe I influenced the substrate directly in front of the last sample, so I go there where we have no turbidity because of my sampling procedure, and then I continue here, which is also mesolithal as I had before. Brushing again, using some waves. And especially in cases of larger stones, if you have larger stones, take them out and brush them, because Bela showed us that there are a lot of snails on it, and you will never get them without taking it out and brushing the stones. sure that all the animals are rinsed into the net completely by doing like this. Maybe avoid that some drifting animals go inside, and then transferring the material into the bucket. Alright, and now I will rinse it again once more. And then we will take a rinsing net and to get rid of the large stones that might be inside here. Then please check the net for oligochaetes, because we always have the problem that oligochaetes are stuck into the net. In that case it's okay.
You should have a water column which is quite huge, so then you try to get the water into a movement so that the animals and the organic material is in movement and not attached to stones. After doing this, you have to do it with try to put all the organic and unorganic material in there, and then you have to do it again and again until no animal is left. But you have to inspect the stones, because at the stones there could be mussels, snails, but also caddisflies which are attached to that, like pupa.
I would suggest to take out the large stones and brush them, and with the rest we have to do it by hand. Yeah, the sorting of Theodoxus in that case. Yeah, it's full of Theodoxus. They're not empty. They're alive, and yeah, we have to transfer it by hand. Otherwise, because they are not floating when we are rinsing. Yeah, they are the same weight as the material, the anorganic material.
But this is a fine result. Red carnomids. We are using a net where it's easier to get rid of the material. You see the worm here? Yeah. So these are duplicate sheets, I guess. I don't know. This is not so good. So it's better you take a net, very fine, small net, which is more easy to detach.
So you can only divide the habitats by going into deeper zones.
Low oxygen, and this affects the water quality, of course, and the living organisms. So we have reddish carnomids and red tubificetes, which have hemoglobin to more efficiently use the oxygen. And you can write this down in the protocol. It's a very good indication for standing waters with low oxygen.
It's black underside.
Yeah, and it smells also.
And it smells.
Yeah.
Znači.
Please smell it. Everybody has to smell it.
Yeah. Yeah, yeah.
Na mulje.
Na mulj.
Da.
Nice. Ta aroma. Ako moram.
So, what to do with the plants? Because if the water level is rising, also those that are floating now will be like this. So this is a good question how to deal with that. I usually prefer the method. In that case I have to go against the rules to do it upstream, because it's stagnant. I would always check the macrophytes, put it inside, and then check for the substrate down there. Yeah, and cut it. Yeah, this is my idea of macrophyte sampling, but I'm open for other recommendations. Yeah. So I will destroy the substrate now and put in the macrophytes. That would be one sample for me. Yeah.
So the macrophytes, sorry to interrupt, the macrophytes that are on the area of the substrate that you are sampling, all of them go inside, and that's it.
Usually all of them go inside. Yeah. And if it's meters long, you should take it, because they cover the area from the ground, the frame. Yeah. So I will take all of them. Okay, now wash it, rinse it, and maybe fill the bucket completely with water so that the macrophyte is completely covered. Do the rinsing and then check it by hand, the leaves. Yeah.
Mesh size
500.
500. Yeah.
500.
The same as the MHS net. Yeah. Okay.
It's like laundry washing.
It's like laundry washing, exactly, and it's always good to have a colleague doing that.
Colleague or two.
Or two.
One of the techniques which was used in all occasions was kick and sweep. Kick and sweep is much easier to take in compared to the multi-habitat sampling, and by our experience, it provides almost the same result if you use indexes. It is a bit, let's say, it's not so good for smaller organisms, but it is more the case in the practice, because when you use the sorting on site, in that case what we did on the Tisa River and in radius 2, in that case we lost a lot of hieronymids, small oligoheads and such kind of organisms, but in radius 3 we didn't do sorting on site, we did it in the lab, so result was almost the same in compared to the multi-habitat. We have to consider to use this side, not this one. You see it's not on the middle of the frame, because in that case you will save the net of not to be destroyed by the stones and so. And you just position the net like this and move and kick underneath. And follow your feet. Several ideas how to standardize this sampling. One is time sampling. For example, you count 1 minute sampling, which is quite exhausting and, by my opinion, not effective. The best one would be to standardize, let's say, 10 trials, something like that. This was one. You use the same for the assessment of habitats. Just roughly assess what is available. You see there are macrophytes, there are some stones, in the deeper part there are some sand. So you use approximately 3 here, 3 in vegetation, 3 in the sand. And one additional one, you can find some woody debris or some big stone which you wash into the net.
I am just leaving it. It is in the direction already. Now I can feel that it is stuck, and Mama pushes a little bit backward. Enough. Totally different habitat. Totally different.
Sediment.
Let's go 50 meters. it's very deep. Slowly. You can feel it. Oh, Dina. Thank you. Estimate the depth. 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe 10 meters. Oh la la! Oh la 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 la!
We have some sponges there too.
Are you sure?
I am sure. Talád és Kovács.
Very good. Third.
So how much are you pulling backwards? How many?
You feel that it's full.
More than full.
Pseudodonta complanata. Look at this. Enough. Yes.
So this one is first.
It indicates very well that we could touch not only the very superficial layer but a little bit deeper, at least to this depth. So probably microscopic investigations could help because there are a lot of oligoheads over there, you can see. It's very useful to take pictures about the sample that we collected, then a picture about the sample which is washed, sorted a little bit. All of these informations are useful. And then the last one.
The third one, deepest.
Pseudodonta complanata. More than 10 meters. Second one was approximately 10 meters deep water. The first sample contains mud. We did not expect it, although we might expect, because this is a shelter. You can see a starting bay, widening bay, so the current deposits here the fine material. This is the first one. The second one is very interesting. It contains large rocks, large gravels, full of corbicula, Dreissena, not the polymorpha but bugensis. And the third one, which was really interesting, we did not expect, mixture of gravel and mud. Gravel and mud. With formerly dyed shells of dyed mussel shells. So you can see what we can do with the processing. The main point is that to decrease the volume of the sample. Obviously we will not have such a diverse fauna in the deep water than what we found here in the bank, but it is very interesting because anyway it is information which we cannot get with any other way. So. This is Hungarian goat pipe, which is special, but not. This is a very widely known instrument in the world. Each nation has its own variety, and this is the Hungarian.